All right, let's take a look at this fun problem here. We are doing a partial fraction decomposition for this problem. So here is our partial fraction, and what we want to do is we want to set these up with our linear factors. So I'm going to set this equal to a, and these are repeated linear factors, so I'm going to have an a over x minus 3 for my first x minus 3, and then I'm going to go b over x minus 3 squared. Now, I know if you're taking that and you're multiplying it out, that means that would be x minus 3 cubed. But with repeated linear factors, we're just going in ascending order until we get the degree that we're going to. Okay, then this next factor, you have x squared minus 1. When you have a quadratic in your denominator, you want to set this up with a linear. So this would be cx plus d. Okay, see, notice how this has, we could say that is bx to the 0, and then that's an x to the first. Okay, so this would be like having 1 degree down, x squared in the denominator, x to the first in the numerator. So that's why we want to do that. Let me just erase that there so it doesn't get in our way. Okay, so this is how we're setting this up. Now we need to find a, b, c, and d. So what we're going to do is we are going to multiply out the common denominator, meaning I'm going to multiply each term by x minus 3 squared, x squared plus 1. So each term will get this. Let me just take a second to write this here. Okay, which means that in this equation, the x squared plus 1 cancels. Here, I'm going to have the x minus 3 squareds canceling, and then here, I'm just going to have one of these guys cancel. And then over here, the entire denominator cancels out. So now what I'm left with is negative 48x plus 14 equals a times x minus 3, x squared plus 1, plus b times x squared plus 1, plus cx plus d times x minus 3 squared. And that cx plus d is a binomial, so I'm going to put a parentheses around it. All right, now looking at my original problem, if I take a look here and I look for any asymptotes or any holes, I could have x minus 3 over here. And if I plugged a positive 3 in, that would give me 0 here. So I'm going to use that as a hole to work through this and maybe find a value here. I'm going to get plus or minus I. That's not going to help me. So this is really the only one that I can use here, my asymptote. So I'm going to plug a 3 in and see what that gives me. Now, when I plug a 3 in here, 3 minus 3 is 0, so this whole thing just doesn't even matter. When I plug it into b, I'm going to get 3 squared plus 1. And then with the c, 3 minus 3 is 0, times all of that, so that goes away too. So this is going to help me find b. So I'm going to get negative 48 times 14. Let's see here, negative 48 times 14 gives me, I'm not multiplying by 14, sorry, negative 48 times 3 plus 14 gives me negative 130. And then this is b, and then that is 3 squared 9 plus 1, 10. So then I'll divide both sides by 10. I'm going to get a negative 13 for b. All right, and that's the only thing that I could find using asymptotes. So now what I'm going to want to do is I'm going to take this, bring it down here, and I'm going to plug the negative 13 in. So I have negative 48x plus 14 equals a x minus 3 x squared plus 1. B is negative 13, so minus 13 x squared plus 1 plus cx plus d x minus 3 squared. All right, now here's where it gets tricky. Since I have nothing else to plug in, I need to equate factors. So in order to do that, I have to multiply this whole thing out. So this is going to be a long multiplication problem. So let's start doing that. So negative 48x plus 14 will stay over here. Okay, now this, I'm gonna take these and multiply this out first. This is gonna be x times x squared. We have a and then x cubed plus x minus 3x minus 3. Okay, and then that is gonna give me an, if I distribute the a, ax cubed plus ax minus 3ax minus 3a. Okay, when I take that and I distribute everything. Okay, then here I'm going to get negative 13x squared and minus 13. Okay, now this, let's see, if I bring this cx plus d down, x minus 3 squared, x minus 3 times x minus 3 gives me an x squared minus 6x plus 9. And then if I multiply all of this out, let's see, I'm going to get a cx cubed, so plus cx cubed. That's going to be minus 6c x squared and plus 9cx. Okay, then plus dx squared. Then plus minus, looks like I'm running out of room here, so I'm going to come just down here, minus 6dx, and then plus 9d. Fun, huh? Okay, so we have all of that out. Now we want to group our like terms. So I'm going to come here and in pink, I'm going to do all my x cubes. So I've got an ax cubed and it looks like a cx cubed. And then that should be it. So I've got ax cubed plus cx cubed. Okay, then x squared, we're going to go orange. So I have a negative 13x squared, and I'm noticing something here. If I go back up here, let's see, x times x squared is x cubed, x times 1 is x, 3 times x squared, that's an x squared right there. So this here is a negative 3x squared. So I've got this guy here, also a negative 13x squared, also a negative 6cx squared, and a dx squared. So for my x squareds, I've got a negative 3ax squared, got a negative 13x squared, I have a negative 6cx squared, and I have a plus dx squared. All right, let's go to a gray for our x's. So I have a plus ax plus 9cx minus 6dx. So that's going to give us, let's see here, ax plus 9cx minus 6dx. Okay, then let's look at just our solid terms here. So we'll go light blue. So that's going to be this negative 3a, negative 13, and plus 9d. All right, so we've grouped everything together. Now what we want to do is you want to take out a GCF from each of these. So if I take out an x cubed here, this is x cubed, and then that is a plus c. Okay, and then the next one here, oh, let me go to the right color. Okay, I can take out an x squared, and that's going to leave me with a negative 3a minus 13 minus 6c plus d. Okay, and then the next one, I can take an x out, and that is going to give me a plus 9c minus 6d. And then my last one, nothing comes out of that one, so this just becomes the same thing. Okay, so now what I have is I have these 4 group terms, and then I'm going to set them equal to factors over here. So if I look at this function on the left, what I started with, there is no x cubed term and there is no x squared term. Okay, so when I set these equal, the x cubed term on this side is 0. The x squared term on this side is 0. There isn't one. The x term is negative 48. Okay, or negative 48x, because we've taken the grouping, we haven't taken the grouping out of everything yet. Okay, and then my singular term is 14. Okay, so you're equating it to the term. Okay, the term that it goes with, x cubed, whatever was for x cubed on this side would go here. There isn't one, so it's 0. There's no x squared term here, so you equate that to 0. There is an x term, it's negative 48. You're going to equate that to x. And then there is a constant term, which is 14. All right, so the next thing that you're going to do is you're going to set this up as a system of equations. So when I do the system of equations here, you really only need 3 of the equations. You can do with 4, but we're going to go into matrices with this. So we're going to do a system of 3 equations. So what I'm going to do is I'm going to just ignore my first one here because I'm going to just make sure it works when I plug it back in the end. Okay, so I'm just going to ignore that one. And I'm going to set up this system. So the system is going to look like this. I'm going to have, okay, so I'm going to have 0. So I'm starting from here, equals, and then I'm just throwing out the x squared. Okay, so I'm just doing this. So negative 3a minus 13 minus 6c plus d. Now, if I'm doing this as a proper system of equations, I'm going to take that 13, I'm going to move it over here to the left. Okay, so it's actually going to be like this. 13 equals negative 3a minus 6c plus d. Okay, then I'm going to take this one here and I'm going to have, doesn't look like there's anything that I need to move over. So we're going to go negative 48. We're going to throw the x out, okay, because we've grouped it out. And then that's going to be a plus 9c minus 6d. And then this last one here, I do look like I need to move something over. So let's see, I've got 14 equals negative 3a minus 13 plus 9d. So let's go ahead and add 13 to both sides. And that's going to give us 27 equals negative 3a. We don't have a c term, and then plus 9d. Okay, so now we have a system of equations. Let's go ahead and solve that. We can solve this using matrix operations. We can also solve this by hand. I'm actually gonna, let's go ahead and do it by hand since we're doing this whole thing into a long problem. So I have equation 1, equation 2, equation 3. Okay, I already have c eliminated from equation 3, so let's go ahead and eliminate c from equations 1 and 2. So that means that, let's see, I'm going to take this equation 1 and equation 2. Let's see, how would we eliminate this? It looks like we can make these both into 18. So if I multiply this by 3 and this by 2, then we can go ahead. So let's see, 3 times 13 is going to give me 39. So 39. And then 3 times negative 3, negative 9a, negative 18c plus 3d. Then over here, I'm going to have negative 48 times 2 should give me a negative 96. and then equals 2a plus 18c minus 12d. And then if I add these together, 39 minus 96 gives me negative 57. Negative 9a plus 2a will give me a negative 7a. These eliminate, and I'm going to get a negative 9d there. Okay, so now I'm going to take these two equations and I'm going to add them together. So I'm going to take equation 3, bring it down here. So 27 equals negative 3a plus 9d. Oh, that's nice. I don't have to actually do anything there. My d's are going to eliminate. So if I take this and add it together, we've got negative 57 plus 27 gives us a negative 30. And then this will give us a negative 10a. And then these eliminate. So then we're going to get a divide by negative 10, positive 3 for a. All right, so we have a. Let's go ahead and go back to one of these two equations and let's solve for d. So I'm just going to use this one here. So I've got 3 is a, so 27 equals negative 3 times 3 plus 9d. So 27 equals negative 9 plus 9d. If I add a 9 to both sides, that's going to give me 36 equals 9d. Divide by 9. I'm getting a 4 for d. So now I have a and d. Now I can find c. So let me use the first equation here. 13 equals negative 3a, so 3 minus 6c plus d, which is 4. So negative 3 times 3 is negative 9 minus 6c plus 4. So that will give us negative 9 plus 4, negative 5. Add the 5 to both sides. We're going to get 18 equals negative 6c. Divide by negative 6. We are getting negative 3 for c. All right, so we've got a, c, and d. We already found b. Remember, b was negative 13. So I want to go all the way back up to the beginning. Okay, and that's what we're plugging in here. Okay, so we're going to take this, what we originally had, we're going to plug in a, b, and cx plus d. So I'm just going to repeat it down here. So we had a over x minus 3, b over x minus 3 squared, and then cx plus d over x squared plus 1. Okay, so we're plugging those in. So a is 3, so you go 3 over x minus 3 plus b, which is negative 3. So let's actually take this and make this a minus 3 over x minus 3 squared plus cx. Oh, I put c there. This should be d. So, or b. B was up here, negative 13, right there. So let's go ahead and fix that. So this is minus 13. All right, and then cx plus d. So c is a negative 3, and then d is 4. So we're going to go plus negative 3x plus 4. And then over x squared plus 1. And now your partial fraction is decomposed, and you are done.